the class. Okay, perfect, Daniel. Thank you. So you can hear okay, right? Okay, good. Thank you, Andres. Good morning. How are we doing? How's the audio on your side?
Hi, good morning. It's also good for me.
Okay, thank you, Andres. Joel, how are you, sir? How's the audio on your side?
Hi, teacher. The audio is okay. It's good.
Okay, perfect. Thank you, Joel. Arturo, good morning. How's the audio on your side?
Hi, good morning. It's good for me too also.
Okay, thank you, Arturo. Jesus, Marco, and Jesus. We've got two Jesus. Please remember to have the camera on while we are
Teacher,
the roll call.
teacher,
Yes.
can you give me a minute to turn on my computer? I don't know if you received the message I sent you, but I was not in my room where the computer is and the webcam. I was in the guest room with my phone, and it was like hard to place it on the table because there's none. It's just a bed. I'm already back in my room. The workers already left. I'm just turning on my PC. Can you give me a couple minutes?
That's perfect. That's not a problem. While I do the roll call, go ahead, Marco. Let's see, Anna. Good morning. How are you, and how's the audio on your side?
Hi, good morning. I'm doing well, and the audio is perfect.
Thank you, Anna. Leo, how are you doing, and how's the audio on your side?
Hi, good morning. Good, and the audio is perfect.
Thanks, Leo. Fernanda, good morning. How's the audio on your side?
Good morning, teacher. The audio is okay.
Thank you, Fernanda. Remember that I'm going to be kind of moving around, so that's part of it. Some things that in other classrooms they've told me that depending on the direction of the speaker, sometimes the audio is affected and there's a lot of echo, and I'm concerned about that. Luis Espinosa, good morning. How are you, and how's the audio on your side?
Good morning. I'm good. And you?
I'm good. I'm good. Thank you for asking. How's the audio on your side?
Perfect.
Thank you. Perfect. Alejandro, good morning. How's the audio on your side, and how are you?
Hi, I'm doing good, and the audio is great.
Okay, perfect. Thank you. Alfredo, good morning. How's the audio on your side?
Hi, teacher. Good morning. The audio is perfect.
Okay, perfect. Thank you, Alfredo. Aime, good morning. How are you, and how's the audio on your side?
Good morning. I'm fine, and the audio is perfect.
Okay, thank you, Aime. Luis Gallardo, how are you? Good morning, and how's the audio on your side?
Hi, teacher. Good morning. The audio is well enough.
Okay, thank you, Luis. Ivan, good morning. How's the audio on your side?
Good morning. The audio is fine.
Okay, thank you. We're excited. Thank you. Perfect, Ivan. Miguel, good morning. How are you, and how's the audio on your side?
Good morning. I'm good, and the audio is good.
Okay, thank you, Miguel. Jesus Rodriguez, good morning, and how's the audio on your side?
Good morning. It's good. Everything's good.
Okay, thank you, Jesus Rodriguez. Jesus Aceves, good morning, and how's the audio on your side? How are you? Jesus Aceves, good morning.
Good morning. Yeah, audio is fine. Thank you.
How's the audio on your side?
Yeah, it's good.
Okay, thank you, Jesus. And last but not least, Marco, you'd already chimed in.
I'm here. The audio is fine. I'm just booting up my PC.
Okay, perfect. Okay, so we're gonna try it out like this for this session. Okay, see how it goes, and you'll let me know, and I'm recording it so I can see as well. I feel more comfortable this way because I'm speaking to the camera, but I'm being able to see you guys. So at least this is a little bit more comfortable for me. I don't know how it felt for you, but I really didn't feel comfortable doing this and being out of the shot, because that's another thing. When the camera's in front of me, I don't know if I'm in the screen or not. So at least for now, this is more comfortable for me. Okay, so we're gonna try this out, see how it goes. Okay, and question, have you had any more classes in this mode? You mentioned that you had classes with Professor Melissa, myself. Any other class that you've had with the hybrid template?
We had one chemistry class.
Okay, good. Was that with Professor Mora?
Yes.
Okay, good. Okay. Remember that each class is different, so each professor might have a different setup, but I'm totally open to hearing things that work for you guys. And so probably at the end, I'm going to ask you, okay? Okay. Let's do this now. Would you guys like to have a bonus activity?
Yes,
All right.
please.
Let's have let's do a bonus activity. I'm totally cool with that. Let me explain the bonus activity. And you can ask questions if you want. By the way, remember, kids, remember, any and all bonus activities, first off, by default, because I'm the professor, are probably going to be weird. Number one. Number two, they are completely and totally optional. If you're too cool to do any of these activities, it's not a problem. You don't have to do them. Okay? However, if you do them, well, you're going to get extra points. That's just the way it works. Okay? So it's up to you guys. If nobody does the activity, there's not a problem. If you guys do the activity, you're going to get extra points. By the way, remember, all the bonus points get accumulated towards the exams. And remember that you can accumulate extra points beyond 100. So if you get 100 in next exam and you have, let's say, 5 extra points for this activity, I'm going to average with 105. You never lose your bonus points. Okay? So this is going to be the bonus point activity. I'm going to explain it. I'm going to explain the dynamic and how you're going to turn it in. And you may ask questions. Is that okay? Let's leave our cameras on for now because we're talking. Okay? Remember, ask questions if you have any questions. Okay, first of all, show of hands. Whom of you have heard the term tesseract? Some of you have. Good. Some of you have. Alejandro, you've heard the term tesseract. Where have you heard the term tesseract? Can you please share with us?
In Avengers.
Correct. What? Correct. You've probably heard it from the Marvel movies. Daniel, could you expand a little bit more about that? You've heard?
Well, I've heard Tesseract also in the Marvel movies, but I also heard it in kind of physic way. It's
let's not talk about spoilers right now. Okay. It's good that you know about it through the Marvel universe, but you also have heard that it's something that has to do with physics and math. Let's leave it at that. Okay. No spoilers about who lives or dies or anything like that. Okay. Let's see, Miguel, you still have your hand raised. Would you like what have you heard regarding the term tesseract?
I've heard it from the Marvel movies as well, but I think it's also a figure, right? Like Kirita and another.
Again, no spoilers, but yeah, it has something to do with math and actually geometry and a bunch of other things and physics as well. Okay, so here's the bonus activity. You may remember one thing. When I ask a show of hands, raise your hands. When we finish, lower your hands so I know that you're not wanting to participate. Oh man, this is extremely more comfortable for me. I was really feeling not comfortable with the other setup where I couldn't see you guys. Okay, so the tesseract or a tesseract, the term tesseract comes from math and from physics. It's something that has to do with math and physics. I'm not gonna get into detail about what it is because the bonus has to do with that. But Daniel and Miguel kind of touched upon a little bit, talking about something that has to do with math and from physics, something that has to do with a figure, etc. A tesseract is something that has to do with math and physics. However, the term tesseract is also used in the Marvel universe. Okay? Now, I need to explain the bonus, I need for us to be a little bit more specific there. Does somebody remember what the tesseract is in the Marvel universe and what it does? Daniel.
The tesseract was used to hold Infinity Stone, and it's like a holder to wield.
Perfect, perfect. It's perfect. Somebody else had raised their hand, but if you lowered it, I imagine that, I think it was, did Miguel, somebody else raise their hand? Somebody else want to participate? Go ahead. Or Arturo? No? Okay.
No.
Okay, so correct, Daniel. In the Marvel Universe, there are the Infinity Stones. The Infinity Stones represent different properties of the universe. There's one particular Infinity Stone, that's the blue one, that's called the Space Stone. It's a stone that has very particular, interesting and important properties relating to the universe. It has to do with space. If I wield the Space Stone, I can do something that would have been really useful right now in the morning. Instead of driving from my home, su casa, to here to Cetis, I could have just wielded the Space Stone and appeared here. One of the properties of the Space Stone is that it can kind of create wormholes. Jesus Aceves, you would raise your hand. Please go ahead, sir.
Yeah, I was going to say that you can teleport anywhere in the universe with the space stone.
Correct. That's one of the many things that you can do with the Space Stone. You can move or transport yourself instantly between different points. So you can teleport. Actually, the concept of teleporting, if you talk about physics, the concept has to do sometimes also with creating wormholes, which is basically a tube or a connection between 2 points in space that are joined together, and you can move from point A to point B instantly. That's one of the properties of the Space Stone. Are we okay up to this point? Those of you who don't like this stuff, you may disconnect and go to your happy place. Be patient. We'll get there. We'll get to the bonus. I know some of you might be too cool for this. That's not a problem. Sometimes you have to be a little less cool to get bonuses, okay? Believe me, I've learned that in life. So the Space Stone can help me teleport and has these properties that have to do with space. If you've seen or read the Marvel lore around the Infinity Stones, the Infinity Stones are powerful objects. What I just said, that I'm going to grab the Space Stone and just hold it in my hand, that unless my dad is a planet or something like that, I'm not going to be able to do that. They are thinking about them as materials, as objects. They're very powerful and maybe even unstable, meaning you just can't have a Power Stone in your house or an Infinity Stone in your home and expect it to not maybe create a dangerous situation. So they are dangerous objects, right? If I were to say to any of you, let's see, Leo.
Yes.
I'm going to tell you right now, Leo, I've got a bar of uranium, and I'm going to give it to you because uranium is very expensive. I'm going to give it to you because I think you're a cool person, and I want to give you something. I'm going to give you a bar of uranium. Would you just grab the bar of uranium and say, okay, cool, I'm going to put it in my pocket, or I'm going to put it in a dresser? Would you just handle the bar of uranium just like that? Yes.
No. No, it doesn't sound like it's it sounds like it's a risky metal or element or kind of
radioactive. It's harmful. So if you're going to be handling uranium, you need something to handle it with. You just can't handle it like that because it's radioactive and it's dangerous. Are we okay up to this point, everybody? Well, an Infinity Stone is dangerous. It's kind of like a uranium bar. You just can't be handling it. So all of the Infinity Stones in the Marvel Universe are housed in something. If you think about the lore, all of the Infinity Stones are housed in something that protects them and contains their power. Well, in the Marvel Universe, they said, well, what can be an object, a thing, a geometry that can house a space stone? Let's use a tesseract. So Marvel didn't invent the term tesseract. That's a mathematical thing, mathematical in physics. But the Marvel folks said, oh, it'd be very interesting. Where could we house a space stone, something that can teleport to contain that energy? Let's use a tesseract. So what is going to be your bonus activity? And it's going to be in many parts, okay? I'm going to explain it and you guys can ask questions. First off, I'm going to activate a discussion forum later today that's going to be called Tesseract Individual Bonus. If any of you write a 2 to 3 page essay where you explain, because you've researched, where you explain what a tesseract is, that's the first part. You need to explain what a tesseract is, and you need to demonstrate that you researched it. Tesseract not in the Marvel universe, tesseract in math, physics. You need to research a little bit and explain what a tesseract is. And then this is the part that's your thinking. After you research what a tesseract is, then you're going to research about the tesseract and the space stone in the Marvel universe. That's the second part. You're going to explain a little bit about that. And the third part is where you're going to link those two up. And you're going to try to explain to me, according to what you researched, why is it science fiction logic to put a space stone in a tesseract? Okay? The 2 to 3 page essay is going to have 3 parts, actually 4 parts. The first part is, what is a tesseract? Do a little research. The second part, what is a tesseract in the Marvel universe? And how is it related to the Infinity Stones? The third part is, okay, based upon what I researched, I believe that the tesseract is used to house the space stone because of this, and this. Okay? All of this is science fiction. The fourth part is the references. So you need to have researched some of this, so you need to include the references. It has to be a 2 to 3 page paper, 2 to 3 page paper individually. If you turn that in, depending on the quality of what I read, you're going to get 5 to 10 extra points in the next exam. The due date for that is going to be, I'm going to activate the forum today. I'm going to give you until midnight of Saturday to turn that in, because we're in the middle of the pandemic. We shouldn't be going out. So what should you guys be doing on Saturday morning? You should be doing this bonus. Okay. So it's going to be available until anybody that turns it in correctly with the 4 parts before Saturday at midnight, you have the possibility of getting 5 to 10 extra points. Questions with that part before I mention another part that might give you more extra points? Questions?
Teacher, you told us the extension will be 3 to 4 pages.
2 to 3.
2 to 3, okay.
2 to 3 pages, and it should have 4 sections.
Yes.
The Tesseract research, the Marvel Tesseract Space Stone research, the part where you're linking those up and trying to explain why
Everything is linked up.
exactly, and the fourth is the references that you consult.
Okay, and what could be the title for this? Just Tesseract research?
Yeah, you could write down at the top of your paper, just write Tesseract individual bonus and your name.
Okay, thank you.
And please remember, let's use this as a rule so I don't have to repeat it and cancel any deliverables. Turn in everything unless specifically indicated as a PDF document. Remember that. Jesus, you're a little bit new to all this, so I'm mentioning things that I've already mentioned, but I'm doing it also so you take note. Anything and everything you turn in should be as a PDF document, unless you ask and I say, well, it's a presentation, you can turn it in as a PowerPoint. But if it's going to be something written, it should be a PDF, not a Word document, not a screenshot, not anything like that. Let's go with Daniel, and then I'm going to mention the other part of the bonus. Go ahead, Daniel, please.
Is it in formato APA?
Yes, please. Let's try to have, whenever I mention references, I'm expecting APA format, please.
And portada?
No, that's a very good question, Daniel. In what you turn in for me, your homework tasks or the bonuses or etc., you don't need to put a cover page. What you can do is that you can just put a header in the document on each page that has your name and your student ID. So you don't have to include it. If you include a cover page, that's fine. But if you don't, you can just put a header with your name and your student ID. Okay. Now, that's the individual bonus. But there's going to be another bonus. This bonus is going to be for the first group that turns it in, not for everybody. And again, all this is optional. I'm going to open another forum that says Tesseract bonus houses. And how's that going to work? The first house that turns in a presentation, this should be, I don't know, maybe a 2, 3, 4 slide presentation about the Tesseract bonus. I'm going to allow that house to present. I'm going to give them 5 minutes on Tuesday's class to present their explanation to the group. And that house is going to get between 3 and 5 extra points. All of the house members, as long as they all participate in the presentation. But that's just going to be for the first house that turns that in. Same due date, Saturday before midnight. Okay. If more than one house turns it in, I'm going to look at the dates, and the first one that's the house that's going to get the opportunity. Okay.
Teacher,
go ahead.
I have a question. You said the percentage is going to be about the same thing we research on the essay?
It's preparing a presentation.
It doesn't have to be as long, right? Or is it going to be like 2 to 3 pages worth of information?
It's a presentation. It's not a paper.
Okay.
It's a presentation. You're going to present to the group. Okay. That can be a PowerPoint presentation. It could be the PowerPoint file, or it can be a PDF file of the PowerPoint, however you want to turn it in. But it's a presentation. By the way, remember last class when I asked for presentations for homework task number 2? Some of you did very good presentations. Your presentations looked good. That I expect that whenever I ask for a presentation. Okay, it doesn't have to be very long. I mean, you could do that maybe in 2, 3 slides, maybe. And I'm going to ask you guys to present. By the way, if you don't present and all of the house members don't participate in the presentation, the extra point is null, and the next house gets an opportunity to do that. Okay. Last question, last couple of questions before we move along. Luis Gallardo, please go ahead.
I know you told us already some points we need to have in the research and in the presentation, but do you have any other like checklists you're gonna upload to Blackboard or something?
It's what I mentioned right now. It's just
okay.
What I mentioned right now.
Thank you.
If you have any questions, you can ask me via WhatsApp at some point. That's not a problem. This is an exercise, by the way. I'm very specific with my indications. So right now, this is one of my experiments I'm doing. I'm just talking about the indications. I'm not going to write them down. That's on purpose. If you guys need to pay attention. For other stuff, I'm going to be extremely detailed, and all of that is going to be written down. But in some cases, I'm going to be explaining it like the bonuses to see if you guys were paying attention. Now, questions before we wrap this up. That's one bonus. You can have more opportunities for bonuses. Questions?
Yes, I missed. Oh, sorry, I forgot to turn my video. I forgot to write down the second and third part about the 4-part essay. What were they?
Let's do this. Who can mention to Miguel the 4 parts of the essay? Let's see if you
can.
Pay attention. Go ahead. Whoever wants to jump in.
So it is what is a tesseract? like the real one? What is it in Marvel Universe? And try to explain in your own words or by what you understand from the research you did, a connection between the Marvel one and the real one.
Thank you.
And the fourth part
And the
is
references.
References.
references. Okay, good job, Daniel. Is that okay, Miguel? Did you get them?
Yes, thank you.
Perfect. Any more questions? No questions? Look, you guys, again, I'm giving you the opportunity of potentially getting up to 15 points in the next exam. Potentially. Okay, so completely optional. Okay, completely optional. Okay, good. If there aren't any questions, we're going to jump back to what we were seeing last class. I am going to jump over to PowerPoint right now. You may leave your cameras on or off as you wish. Okay. Okay, so this was the last exercise that we did. By the way, you guys remember, as of right now, I'm going to be updating the PowerPoint presentation probably after each session, but certainly after every week. So this PowerPoint is already available in Blackboard and already has the detailed solutions that we did last class. Okay, remember, you're always going to have the detailed solutions in the PowerPoints. Okay. And so this was the last exercise we did, if I'm not mistaken, and we solved that inequality by two methods. Okay. Now, let's see some other exercises that have some variants of this. And remember, you guys, if you guys have any questions, remember, please go ahead and raise your hands or jump in at any moment, okay? Please feel free to do so. This is basic, I'm gonna say this is basic kindergarten math, okay? And you guys know this, these are the laws of the science, okay? You guys know the laws of the science. So if I have two numbers, plus times plus or minus times minus, meaning two numbers, two quantities that are of the same sign, the result is always going to be
Positive.
positive. If I have two quantities, two real numbers, and the signs of these are different, plus and minus or minus and plus, the result is always going to be
Negative.
negative. Correct. This is kindergarten math. We're not talking about anything. We're not talking about rocket science here. However, this kindergarten math, not remembering this kindergarten math, can get you in trouble with the inequalities. Can get you in big trouble with the inequalities. Because remember that we were talking about the flipping of the sign. That's going to be a problem if we don't remember the sign properties or the sign rules. Okay, so yes, it's basic. It's going to be basic kindergarten math, but we need to remember it. Okay. So we are going to be the inequalities that we solved previously. These inequalities here are called linear inequalities. Does somebody know why these are linear inequalities? Can somebody take a guess?
Because there's no like exponents.
Good. Good, Andres. Let's talk about what you mentioned and be a little bit more specific. It's not that there aren't any exponents or powers. It's that what is the maximum exponent that we have here in this x?
1.
1. this x is elevated to the 1. So the highest exponent that we have is 1. And whenever we have a mathematical expression where the highest exponent is 1, we call those expressions linear. They're linear. So since the maximum exponent was 1, we're talking about linear inequalities. Okay, linear inequalities behave a certain way. But now we're going to be talking about non-linear inequalities. So based upon what Andres and I were talking about right now, let's see, Andres, help me out here. If a linear inequality, I have just defined it, or a linear mathematical expression, I have just defined it as one in which the highest power for any variable or every variable is 1, then what would a non-linear inequality be, or a non-linear mathematical expression be? By that definition, Andres, what do you think?
Well, like a square one, I guess.
That's an example, correct? But would a square one be the only
No.
possible?
Well, there's also cubic, I think.
And what goes after cubic?
To the 4th power,
And after the 4?
the 5th,
And after the 5th?
6th.
And we could go on forever, right, Andres?
Yeah.
So anything that is not any mathematical expression where the highest power is not 1, we would consider that nonlinear. Now, I'm going to stay with you, Andres, just because you answered brilliantly. Are the possible values of the exponent only 1, 2, 3, 4, 5, 6, 7, etc., or are there other possible values for an exponent?
Well, I guess it could also be negative or a fraction.
Correct. Well done. So for example, I could have an expression, if you guys would agree with me, I can have an expression that is x elevated to the -1. Would you guys agree with that? That's possible, right? Well, that is also non-linear. Okay, that is also non-linear. So any mathematical expression where the highest power of any of the variables is not 1 or different than 1, we consider this as a non-linear mathematical expression. And actually, non-linear mathematical expressions have certain properties that that we have to deal with them a little bit different than how we would deal with a linear expression. And so we're going to use a method called the sign chart method to solve nonlinear inequalities. By the way, for those of you who have already seen inequalities in previous courses, this is one method to solve a nonlinear inequality. It's the method I'm going to be using here. Why am I going to be using it here and showing it to you? It's because I believe it's a very systematic method, and I like things to be structured and have steps and be very ordered. That doesn't mean that you can't solve it using another method as long as you're using correct math to do it. This is just a way we're going to be doing it here. So the sign method, what the sign method does is that it grabs the nonlinear inequality, it tries to find certain critical points of the nonlinear inequality, which are the roots, and we're going to be talking about that in a moment. And based upon the roots, and the roots are going to be the values that make the expression 0. And since 0 is a reference for positive and negative, based on these intervals, we're going to be able to solve the inequality or be able to find the ranges of the inequality that are valid. And so let's look at an example. So we've got that inequality there. X squared is larger than -2x plus 15. Would you all agree that that is a nonlinear inequality? Right? That is a nonlinear inequality. Jesus Aceves, why is that a nonlinear inequality?
Because the x is squared.
Correct. Correct. Well done, Jesus. Because the largest exponent that we have in the expression is not 1. So the largest one is 2. So that automatically it's nonlinear. Automatically, I can't just use the same things I used before. And so there's going to be certain steps to solving these, okay? And I'm going to be going through these steps for this example, and you guys are going to do some examples yourselves, okay? Remember that I'm testing out some things, so again, be patient. I'm testing out writing on the tablet, but what I'm noticing is that my writing is by default not very good, and so it's also affected by perspective, I'm noticing. So let me just give it a try here to see how this goes, okay? And I'm going to be talking about the different steps we need to follow. And if at any moment you guys have a question, please just go ahead and let me know. The first thing that we're going to do with a nonlinear inequality is that we're going to try to represent the inequality where there's part of the mathematical expression on the left, the inequality symbol, and on the right, we want a 0. That's the first step. We're going to represent it as something, inequality symbol, 0. Okay? So I'm gonna try to do that right now. So that's gonna be step 1. Okay. So what we're gonna do here is that we're gonna have x squared. If with any step you guys have a question, let me know. Plus 2x minus 15 is larger than or equal to 0. What did I do there? The only thing I did there was to grab what was on the right and bring it to the left, using the sign properties that I can use for adding and subtracting. And that gives me an expression where I've got the mathematical expression larger than or equal than 0. Okay, that is, we're going to be calling this step. I'm going to call this step 0. Why am I calling it step 0, by the way? Because maybe in an exercise, they're already giving you the mathematical expression like this. And you don't have to make it relating to 0. But if you don't, that's the first thing you need to do. Are we okay up to this point? Remember, any questions, please jump in. Please jump in. The next step that we need to do is that we need to find the roots. The roots of the mathematical expression are going to be these values that make the mathematical expression equal to 0. So we have a quadratic equation there. So there's going to be 2 values that make that expression 0. We did an exercise of these, if you remember, in the diagnostic exercise. And remember that there's many ways to find the roots. One way to find the roots is to directly use the general formula. Directly use the general formula. The other is to try to find some sort of factoring that can give us the 2 roots. What do you guys see there? What could we? Oh, whoops. Yeah. What do you see there? Is it possible to factor that expression?
Yes.
Yes.
Yes. Does somebody have the factors?
With 5 and 3.
5 and 3, perfect. Just give me a moment here because I paused. There we go. What values did you say? What values did you say again?
5 and 3.
5 and 3, perfect. Perfect. Remember, if at any point we have any questions, please let me know. So what we could do here is that we can say that x I'm going to write it down like this. Same expression. We've got 5 and we have a 3. What is the common? What are the signs of that 5 and the 3 in that factorization? Can somebody tell me?
Plus 3 and minus 5. No, minus 3 and plus 5.
Minus 3 and plus 5, correct. And how do we know that? Let's talk about this. It's minus 3 and plus 5. So oh, Jesus, you have your hand raised. I'm going to go with you to you in a moment. Okay. So 3 times 5 gives me minus 3 times 5 gives me minus 15. 5x minus 3x gives me 2x. Okay, that's how I know that those are the factors. Okay.
Sure.
Jesus Aceves, you wanted to make a question, please go ahead.
No, I wanted to answer that. I was going to say the same thing as that. Like, how do we know 3 is minus and 5 is positive?
Yeah, Jesus, you're going to look at the numbers. So I'm gonna do it like this. This number.
No, I already know how. I wanted to answer.
You were gonna answer. Okay, perfect. Thank you, Jesus. Thank you for clearing that up. This would be step 1. Okay, this would be step 1, the factorization. And I'm going to go with you, Luis Gallardo, in a few seconds. This would be step number 1, to find the roots. Okay. By the way, this session is being recorded, and I'm actually going to upload this session to Blackboard via a YouTube video. So you can have it there. I'm going to be uploading some of the sessions that have problem solving. I'm going to upload them to Blackboard so you have that available. I think Luis Gallardo, you had a question. Please go ahead.
Yes, I'm not sure if it's like I don't know if we can call it like a rule, but if not the middle number, in this case the positive 2x, if it's positive there, it doesn't mean that the greater number. In this case, 5 will be positive.
Yep. That's actually you can call it a rule or a guideline. That's correct, Luis Gallardo. We've got 3 in a quadratic equation. We have three elements. Now there's one observation or one caveat there, Luis. The x squared doesn't have anything multiplying it. So the x, we don't have 2x squared, 3x squared, or anything like that. But we can look at the sign of the linear component, which would be the one of the x, and that sign should be the sign of the largest root. Okay. We could use that guideline. Okay. We can just validate that. That's the only thing that we have to be careful with. But that's a good observation, Luis. Well done. Let's take a 10-minute break, and we'll come back and finish this one up. Okay, I'm going to pause the recording.
Teacher.
Yes.
Is it the same as tesseract and a hypercube?
Let's not do any spoilers. There can be different names for the thing. Okay, but I think well, the only thing I'm going to say is that you're on the right track with what you're researching. Okay. And it has to do with 1 dimension, 2 dimensions, 3 dimensions, 4 dimensions, and more dimensions than what we're usually used to talking about in real life.
Yes, is that sometimes what happens is that I get into the YouTube void and I just start watching things that.
Yeah, and there's surely a bunch of videos in YouTube. There's a lot of references. Again, a tesseract isn't a tesseract or a hypercube. Isn't something new, by the way, and it isn't something that has to do with science. Well, it doesn't have to do with science fiction, but it is part of the physics and math where you kind of need to use your imagination because it's talking about certain things that aren't necessarily clear to any or we're used to talking in normal geometry. But yes, you're on the right track. By the way, you guys, when we're on break or anything like that, if my camera is off, it means I'm not here. maybe I went to have a drink of water or I'm doing something. So if my camera's off and you're trying to talk to me or anything like that, it means I'm not here. So wait until the camera is on. Okay. See you in 10 minutes. Okay, you guys, we're back. Let's do a quick roll call here. Please turn on your cameras, please. Everybody back, wakey, wakey. Quick roll call. Everybody with your cameras on, quick roll call. Luis Gallardo.
Right here, teacher. Good
Hi,
afternoon.
hi, Andres.
Hi, teacher.
Hi, Aime.
Hi.
Hi, Daniel.
Hi, teacher.
Hi, Fernanda.
Hi, teacher.
Hi, Arturo.
Hello.
Hi, Ana.
Hi, teacher.
Hi, Leo.
Good afternoon.
Hi, good afternoon, Alejandro.
Hi, teacher.
Hi, Luis Espinosa.
Hi, teacher.
Hi, Jesus Rodriguez.
Good afternoon, teacher.
Hi, good afternoon, Alfredo.
Hi, teacher.
Hi, Joel.
Hi, teacher.
Hi, Jesus Aceves.
Hello.
Hello, Ivan.
Hi, teacher.
Hi, Marco.
Here. Hi.
Hi, hi, and Miguel. Turn on your camera, please, for the roll call. Going once. Going twice. I'm gonna be very slow because I don't want to put somebody in the waiting room. Going 3 times. Miguel, last warning. Are you there? Turn on your camera and let me know you're there. Please, Miguel. Whoops. We are going to have to send you to the waiting room. And I'm doing this very slowly to see if you answer, Miguel. Okay.
Hello.
Hi, cameras on for the roll call, please, Miguel. Perfect.
Sorry, I was in the bathroom.
Don't worry, don't worry. Right on time. You were right on time. Okay, let's continue. By the way, you guys, I'm going to give you an insider's tip relating to my classes. Let me just verify something here. Yep. So there's 17 of you. And for example, in today's class, there's been about 4 or 5 of you that have participated. And actually, I'm taking note mentally of that. That's very good. There's some of you who haven't participated. That's not a problem. However, I'm also noticing people who never participate. And you know what? I'm going to call upon you at some point. What's the best way for me to not put you on my not participating list that I have to call upon? Participate. Okay? Participate. And I'm taking note of who's participating, by the way, mentally. So just remember that. You're not going to be able to be completely quiet in this class. I am going to call upon you. And if I call upon you and it seems like you don't know what's going on, I'm also going to take note of that. So the best way for me to not do that, or for you to not be on that list, is to participate. Okay, that's what I'm going to ask you guys. Okay, so we're going to continue with this problem. Step 0 was representing it as an expression with the 0 on the right. Step 1 was finding the roots. And we find 2 roots, which is x equals 3 and x equals -5. Remember that one is the factorization, the other is when we find the roots, the signs change. So x3 and x -5. The next step that we're going to do, by the way, I'm doing this problem very, very slowly and with all of the steps, and this is being recorded because there's going to be a bunch of problems in the next homework test that have to do with this. So I recommend you follow the steps, okay? And that's why I'm doing it, okay? If you follow the steps, the probability of you making a mistake in the problem goes down. Whenever we're systematic in doing something, the probability of error goes down. Now, what is step 2? Step 2, what we're going to do is that we're going to establish intervals based upon the roots. And these intervals are going to go from -infinite to infinite, placing the roots. So I'm going to start off in -infinite. Imagine I'm going Imagine I'm going through the number line and I'm going from minus infinite. What's the first number I'm going to find between the 3 and the minus 5? Let me.
-3.
Nope. Let me.
The -5, no?
It's 5. Let me rephrase that. This is the number line. Okay. This is minus infinite. This is infinite. And this is 0. Would you all agree that the 3 is somewhere here? And the minus 5 is somewhere here? We okay up to that point? I'm going from left to right. And I'm going to try to identify all of the possible intervals that contain these two numbers. So if I'm coming from minus infinite, what is going to be the first number I'm going to find, or the first section? From minus infinite to minus 5. And then I'm going to have the 5. And then I'm going to go from 5 to, I'm sorry, from minus 5, and then what's the next number? From minus 5 to 3. And then I'm going to have the 3, and then I'm going to have from 3 to infinite. This is step 2. I'm going to grab, based upon the roots, I'm going to grab all of the possible intervals or sections that the number line is divided into based upon the roots that I have found. This would be step 2. Okay. I'm going to take the screenshot of this. Questions up to this point? Okay. Once we've done that, the next thing we're going to do, I'm gonna, by the way, again, I'm more than happy to make life easy for you guys. So I'm going to jump over to the next screen, but I am going to share with you that this screenshot of what I just did here. Okay, just so you guys can have that. I'm going to jump over to the next screen. So this is the screenshot of these two steps here. I just sent it to the chat. I'm going to jump over to the next screen. This is another way of saying I'm going to erase the whiteboard. Okay. I'm going to clear, and I'm going to go over to the next screen. What we have in the next screen is a table that we're going to call the sign chart. Now, how do we fill in the sign chart? We're going to fill it in like this. Let's see what color I can use. Let's see if this color works out. What I'm going to be putting in the rows, are the factors that I just found. So here I'm going to write down X. What was it? Was it +3 or -3?
Minus, I think.
Minus, right? And then over here we had X +5. And here I'm going to write down the product of these two, which is the expression that I'm talking about. I'm going to leave the last row blank for now. What am I going to write down in the columns? In the columns, what I'm going to write down are the intervals that I just found. So I'm going to write them down here. You guys have them there. So call me out if I make a mistake. It's going to be -∞ to, what was it? -5?
Yes.
Then I didn't like the way that Gonna be minus infinite and -5. Then there's gonna be the -5. Then there's gonna be -5 to 3. 3 and 3 to infinite. Okay, that's the way we fill out the sign chain. Okay, and now I'm gonna be asking some questions to those of you that may not have participated. Let's see, Aime, are you there?
Yes.
Aime, okay. Aime, look at the table, please, and see if you can help me answer the following question. X minus 3. Choose any number that is between minus infinite and -5, whatever number you want.
-7.
Could you say that again, please? Louder? 7 isn't between
-7.
-7, perfect. If you substitute -7 here, I meant in X minus 3, what are you going to get?
Can you repeat?
If we substitute, you just chose -7. If we substitute -7 here, what is going to be the result?
-10.
Yes. What? Don't doubt. Some answers have some questions have simple answers. -10, correct? I mean, is -10 positive or negative? I'm gonna ask you to speak a little bit louder, I mean, and maybe leave the microphone open, because when you switch it on or off, we get cut off to what you say. Could you please repeat?
Negative.
Is negative, correct. I may choose another number between -5 and between minus infinite and -5. Any number you want.
-10.
-10. If I substitute -10 there, what am I going to get?
-13.
And is -13 positive or negative?
Negative.
So I may, would you agree with me that if I substitute any number that is between minus infinite and -5, I'm going to get a negative number? Would you agree with that?
I'm agree.
Perfect, right? I mean, and we could be here all day. I could ask you to choose a million numbers between minus infinite and -5. And the thing is, it's always going to be negative. Okay, thank you, I may. Let's see. Alfredo. Oh, sir. Alfredo. If I substitute the -5 here, now I'm here, Alfredo. If I substitute the -5 here in the X minus 3, what am I going to get?
Well, -7. -8, sorry.
Minus what?
8.
-8. Okay, perfect. Is -8 positive or negative?
Well, negative.
Negative. Let's everybody, let's answer with a little bit more secure, more assurance when it's negative. It's negative? No, it's negative. We're just interested. This is why this is called the sign chart. We're just interested in the signs. Thank you, Alfredo. Anna. Hello, Anna.
Hi.
Please choose any number right now. Give me a moment. Right now, we are in the third column. We are right here. Choose any number between -5 and 3. There's a very easy number we can choose. Choose any number between -5 and 3.
2.
2. Positive 2.
Yes.
If you substitute positive 2 in the X minus 3, what are you going to get?
-1.
It's negative, right?
Yes.
You choose another number.
-1.
If you substitute -1 in x minus 3, what are you gonna get?
-4.
So it's negative, right? So if we
Yeah.
there's a very easy number that we can choose, Anna. We could choose 0. Would you agree? And if I choose 0, what am I gonna get?
-3.
So it's always negative. Would you agree, Anna?
Yes.
So we've got a negative here.
Teacher, I have a question.
Yes.
Can we substitute number 3? Or is that not allowed?
Oh, good question. The roots are treated separately. That's why we have the -5 and the 3 in a separate column. You see that, Ivan?
Yes.
So, but I'm gonna stay with you. What happens when I substitute the 3?
You get 0,
I
which
get
is
0, perfect. I get a 0.
positive.
And remember that 0, we're gonna consider 0. We're gonna consider 0 in Switzerland. 0 is neutral. Thank you, Ivan. That's a good question.
I have a doubt.
Go ahead. Remember to, if you can raise your hands, because sometimes who's speaking? I can't see all of you. Luis Gallardo, go ahead.
Yes, why do you put number 3 in the column if it's in parentheses and I think it doesn't count when it's in parentheses?
Oh, that's why I'm putting it outside. That's why I'm putting it separately. It's
But
not.
just but you put it in the chart just to make clear it's gonna be 0 or?
Yes, yes, that's exactly the reason, Luis, because we're gonna fill in the whole chart and we're gonna see in a few moments why it's useful, but that's exactly the reason.
I can use 2.9999 but not 3, all right?
Exactly, yeah.
Thank you.
So the roots are always gonna give us a 0. That's something that we're gonna find out. Leo, let's go to the last interval.
Yes,
Choose any number between 3 and infinite.
4.
What happens if I substitute the 4 in the x minus 3? What do I
What?
get? 7. Is 7 positive or negative?
It's what?
Is 7 positive or negative?
Positive.
Positive. Leo, would you agree that if you choose any number between 3 and infinite, you're always going to get a positive number when you substitute?
Yes.
Okay, so notice what happened in that row. We have negative, 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 0, positive. Usually the 0, going back to Luis's question, the 0 is going to mark a change in the sign for the factor that has that root. Now, we're going to go quicker. We're going to go quicker. I did that one slow because I'm trying to make this explanation slow so you can have it recorded, but we're going to go quicker. Fernanda.
Yes, teacher.
Did you understand what we did? We grabbed the first row and we just tried to look at the signs that correspond to each interval. That's what we just did, right?
Yes.
Help me out. You and I are going to do the whole second row. I'm not going to go one by one. Help me out here. If it was understood, now let's go with the second row. What sign would I put here?
Negative.
If I choose any number between -∞ and -5, I am going to get a negative. Correct.
Yes.
What happens when I substitute the -5?
It's 0.
0. And since you were paying attention, and this is the part that has to do with magic, what do you think is going to happen with the rest of the row? What happens when I grab a number between -5 and 3?
It's gonna be positive.
Yep. What happens when I put the 3?
Positive also.
And what happens with the 3 to infinite?
Positive.
Perfect. Perfect. Thank you. Well done, Fernanda. We're almost done. Let's see. Let's see. I want to volunteer. I want to volunteer. Who wants to volunteer? I don't make me volunteer someone.
Me, teacher, I can do it.
Perfect, Luis. That's the attitude. When I say who wants to volunteer, it's like somebody raise their hands and step up. Well done, Luis. Help me out with the third row. The third row is actually very easy. The third row, Luis, is basically what happens when I multiply these two.
Okay,
What
so
happens when I multiply these two? Minus times minus, what am I gonna get?
minus. Minus times minus positive.
Uh,
You said,
We're gonna rewind, please.
I thought you said minus plus
Please, we do the multiplication of those two. Minus times minus is
positive.
perfect. You made absolutely no mistakes when you said that, because we rewind. Minus times negative is?
Minus,
Sorry, I said that wrong. That was my fault. Minus times 0 is
minus times 0, 0.
0. Minus times plus is
Minus.
0 times plus is
Again,
0. We're in this column. We're-
0 was plus.
Nope, let's rewind again. We're in this column. 0 times plus is
0.
0.
0. And we're still with you, Luis. Plus times plus is, we're in the last column.
Positive.
Positive, perfect. Thank you very much, Luis. So this would be step, what we just did, which is filling in the sign chart, would be step, this is step 3. Okay. And we're almost done here. We're gonna go here to the last row. And the last row is, I'm gonna call it the evaluation. In the expression that we're talking about, and I'm gonna rewrite it here, by the way, because we don't have it here, just so we can remember. We rewrote the expression to be x squared plus 2x minus 15 is larger than or equal to 0. This expression is equivalent to this one, right? So if the expression, the new expression that I'm working with, the one I wrote in blue, if it says it's larger than or equal to 0, would you agree that we're talking about the expression being positive, including positive or 0, because it says larger than or equal to 0. Then we're going to look at our sign chart and say, okay, is the result of the multiplication for this interval, is it positive? Yes, it's positive. Is the result of the interval or factor 0? Yes, it's 0. Is the result of the multiplication or the factors for the interval negative? Yes, it's negative, but we're not considering negative values. Is the result 0 in this case? Yes. Is the result positive? Yes. And so the result or the solution to this inequality are going to be all of the intervals that comply with the sign chart. This is going to be a little bit filled up here. I'm going to save this. Okay. And what can I do here? Okay. The solution, which would this part here would be step 4. The solution for this inequality would be I'm gonna write it down. Let's see where it can fit. I'm gonna write it down here in the bottom. The solution is going to be from -5, I'm sorry, from minus infinite to -5, including the -5, as well as from 3 to infinite. What I just wrote down in green, this would be the solution to the inequality. The range that complies with the sign that we're talking about is the solution to the inequality. This is the sign chart method. Okay. Questions with this before I comment a little bit on some variations to this? Questions?
I have a question, teacher.
Yes, go ahead. Andres.
I don't understand why you didn't use the middle one.
Okay, good question, Andres. Let's look at, let me just do the screenshot here. This is what I'm writing down in pink, Andres. This is the original inequality that I want to solve, right?
Yes.
But remember step 0 that we represented it like this, right? What we're going to look at, Andres, is the sign. We're going to look at this part here. This part here. Do you see that it says larger than or equal than 0?
Yes.
So larger than or equal than 0 means positive, including 0. Which of the intervals give me combinations that are positive or 0? The ones that
I see.
green. Okay. Now, is that part clear, Andres?
Yes, I understand.
Now, Andres, taking advantage of your question, let's assume now, Andres, that it doesn't say, let's assume that it doesn't say less than or equal. I'm sorry, that it doesn't say larger than or equal. Now let's assume that it says less than or equal. How would the solution have changed, Andres?
Well, I guess the first and the last terms wouldn't like be used, only the second, the third, and the fourth.
Correct. Based on if it's large, that's why in step 0, we leave it with regards to 0. It's easier to compare. This is kind of a rule. It's when we're talking about inequalities, it's easier to compare with regards to 0. Because to the right of 0, we have positive, to the left of 0, we have negative. And so depending on if it's larger than or less than, we're going to look at the sign chart and look at the intervals that are either positive or negative based upon what the inequality is asking us. Okay? I'm gonna, remember, all of these solutions are gonna be in the complete PowerPoint, and I am going to upload I'm gonna upload this video to YouTube later today. Questions with, we're gonna be doing more exercises, don't worry about that. But questions with this one. I tried to go pretty slow on this one so we could so we could have a very, very slow step-by-step example. Questions with this one.
Teacher, can we do the exercise without using the sign chart and just writing down the interval with the union at the step 2? I don't know if I'm being clear.
Let me try to understand. Meaning, let me see. Let's see, who spoke? Was it Ivan?
Yes.
Yes. Okay, Ivan. Let me see if I understand your question. Let's say that this problem is in the exam. And instead of doing the sign chart, you just wrote down the interval after step 2. So you found the roots and then you just wrote down the interval. That's what you're asking?
Yes. Can we do that, or Is there something?
That in the exam, I would probably either put that as a wrong. So you would probably have 0 points or half the points of the problem.
Okay, so
Why do you think that?
because we are not like comprobando the results basically.
You're not demonstrating how you got to that result. By the way, I'm not saying that the sign chart is necessarily the only method. What you could have done, another way of doing it, is identify the intervals and give them values and do a table. Another way of solving these equations is using the graph of a parabolic, the graph of a parabola. But we're actually going to be talking about that further on. But if you just put the result, I'm not going to know how you got to that. So the sign chart method is a way of doing it. You don't necessarily have to do the whole table, but at least if you do the table, I understand the reasoning, how you got there. If you don't do the table, you need to at least show me how you got to that solution. And by the way, I'm going to give you guys a recommendation. The reason I'm showing you the sign chart is because the sign chart is systematic. If you do it correctly, you're going to get to the correct results. If you try to infer things, by the way, what do I mean by infer? Infer is kind of what Ivan is talking about. Well, this is a relatively simple problem. I've got the roots, and I kind of noticed by looking at it that that's going to be the solution. That's wonderful. But if I give you a more complex problem that has a few twists into it, using inference can be pretty dangerous because you might not get to the correct solution because of not doing the correct assumptions. And that's probably the biggest mistake I see in exam number 1. That's the reason that students get a bad grade in exam number 1. That instead of doing things systematically and demonstrating the answer, they try to infer things. And if the problem has some sort of twist or is complex, then that can generate a problem. Okay, so you don't necessarily have to do all these steps, Ivan, but at least show me how you got to that solution. Some of you might have already seen these topics in high schools. So maybe you know the parabola method, which is another method. I'm not going to cover it right now because there's a part of the course where we're going to be talking about parabolas. So I'm going to wait until then. If you know that method and you want to use it, that's fine as long as you use it correctly. I'm not going to talk about that method right now because I don't want to generate confusion with the people who don't know it yet. And so we're going to see that method when we get there. Okay. Is that okay, Ivan? Are we clear?
Yes, it's clear.
Okay.
Thank you.
Perfect. Okay. Now, any additional questions before I clear this? And don't worry, by the way, we're going to be doing a bunch of examples of these, and you're going to be doing a bunch of exercises. This isn't the only example we're going to see. I'm going to clear the drawings, and before we do another example,
Teacher,
yes, go ahead.
I have a question. It's not about the exercise. Are you gonna upload this recording to Blackboard?
Yes, I just said that.
Okay, okay.
If after the class, usually the recordings are going to be uploaded to Blackboard the same day or the day before. So the recordings are going to be YouTube videos. So you don't have to download any large files or anything like that. There's going to be a section in Blackboard that's going to be called video classroom recordings. And it's going to be a link that has the date. So it's going to say class session of August 26th, 2021, and there's going to be a link, and the whole video is going to be there for the classes that I record. So you should have it later today.
Okay, thank you. I just kind of had a lag spike and I couldn't hear the things. Like before you said it.
Yes, don't worry about it. It's fine to ask questions. Don't worry about it. It's going to be uploaded later today, as well as the updated PowerPoint presentation with the solutions. Before we do another example, let me talk about the next workshop. Okay, please pay attention with this. Please pay attention because I don't want for us to do any mistakes. Remember that we're going to be doing workshops. What is a workshop? Remember that my philosophy about math is the following in this type of math. You need to practice. You need to practice. You need to practice. Why? Because practice doing problems and practicing doing problems is the only way your brain is going to understand that there are variations to procedures and for you to look at these many variations and understand what you need to do. Does that make sense? That's my philosophy to math. So if you just do this example and you see the video, but I give you a different example and you don't understand that there are different variations, then you're going to be in trouble. So we're going to be doing 3 types of problems. One is like the one I just did. I'm going to do a procedure. You're going to have the procedure. You're going to have the recording, and that's the example. Maybe you paid attention in class, and that's fine, and you took notes, but if you didn't, you're going to have the recording. Perfect. You are going to have to do homework tasks. And homework task number 3, I'm going to jump over here to Blackboard. Log in here. In your block, and this is recorded as well, so if you don't remember, you can check it here. Here in Blackboard, there is a link here. You're seeing my Blackboard right now, is that correct?
Yes.
You're in the Blackboard? Okay. There's a link here that says homework task deliverables. And notice that there says homework task number 3, due date Monday, September 6th before midnight. This is an individual homework task. And if we click this homework task here, it's a bunch of problems that you guys need to do. Okay? It's a bunch of problems that you guys need to do. Each homework task, I think it's around probably between 20, 25 problems that you guys need to do. By the way, you are only going to do the odd problems. You're only going to do the odd problems. You have to turn in a homework task with the solutions of this problem. That's individual. That's by September 6th before midnight. Okay? By the way, you can do them by hand. Okay? You can do them by hand. You can do them in your notebooks. You can take a picture of that, put it in a Word document, convert it, or a PowerPoint or whatever, convert it to PDF, and you're going to turn in the PDF. Okay? But you may do it by hand. You don't have to do it you may do it by hand. A couple of things, you guys. And this is being recorded. So I'm actually going to be very strict in this homework test. If somebody doesn't do what I just said, you're going to have a 0 in the homework test because I'm saying the indications and it's being recorded. Number 1, please try to be clear in your writing. I'm the one to talk about that. My writing isn't wonderful. My writing isn't the best writing in the world, but I try to do my best for it to be clear. Please try to be clear in your writing. If I can't understand it, I can't grade it. Okay? Secondly, I've mentioned this a bunch of times. I don't know if I've mentioned it 100 times, but I know that I've mentioned it more than 10 times. Turn in a PDF. If any of you, there's 20 problems here, around 20 problems. Let me tell you what students have done after I've said 20 times that they need to turn in a PDF. They turn in 20 images. By the way, 20 bad images. That's what they upload to Blackboard. They upload 20 images that they took on their cell phone, and that's the homework test. If you do that, I'm not even going to give you an opportunity to turn it in again. It's a 0. It's a PDF document. Okay? and please be clear in your writing, okay? Is that clear? Questions there? By the way, you have access to the Jorge Sosa kind of 24/7 hotlines. What does this mean? If at any moment, any of you has a question with a problem, you may send me the question. What's the usual way I work with students? What students do is that they take a screenshot of the problem they're working on, and they send me the screenshot via WhatsApp saying, I have a question. I don't know what to do here. Is this correct? And it's really easy for me because I have my cell phone with me almost all day. And so it's very easy for me because you might send me that screenshot at 10 p.m. on a Wednesday. And do you know what we do in Sukasa on Wednesday afternoons, at Wednesday night, my wife and myself? My daughter, no, because she just watches the iPad. Do you know what we do? We watch RuPaul's Drag Race All-Stars. So I'm probably going to be in bed looking at the lip sync for your life. No, we do that on Thursday. On Wednesdays, we watch What If. On Thursdays, you're sending me at Thursday at 10 p.m. and I'm going to be with my wife looking at the lip sync for your life, and I'm going to get a message with a problem. And since I'm multitasking, what I'm probably going to do is click the screenshot and say, okay, and I'm going to write on it. Okay, this is where you need it, and I'm going to send it back to you. If I don't respond, it's just because I'm probably asleep, or probably the lip sync for your life is really, really entertaining. But I assure you that my response time is very, very quick. I'm going to make a statement right now, and any of you can call me on that statement, and I'd be even happy for you to do it. I don't think you're going to find a professor that has a quicker response time to questions than myself. And if you do, tell me who it is so I can congratulate them, because that's my philosophy as a professor, okay? Now, be smart about it. Ask me a question about the problem. Don't send me the problem so I can solve it and send it back to you, because I'm not that stupid, okay? So please, ask me a question. Send me the problem. I don't know what to do here. Is this correct? Is this solution correct? And I'm going to answer you. And it's probably going to be quick. And if it's in the weekend, it's probably going to be in the weekend. The anecdote that I like to talk about is a couple of years ago when we still traveled, and I mentioned this to you guys, I believe. I was in Milan with my wife because I had gone to a conference over there. And I was in Milan with my wife, and we were having dinner next to Il Duomo. It was very beautiful. In the evening, we were drinking an Aperol Spritz. We were having a wonderful time. And the time difference was about 8 hours. And I was receiving, and the students had homework task number 5 or 6, the math students. And they were sending me screenshots of problems. And actually, I told my wife, just give me a minute, give me a napkin. And I wrote the solutions in the napkin, or the answer to the question in the napkin, took a screenshot, and then I was having my drink and all that. And that was really fun for me to be able to say that I did that. So please take advantage of that. The only reason you guys can have a doubt and that doubt not be resolved is if you don't ask it. Okay? So please, don't go the failure is not an option route where you don't ask any questions and hope that everything goes well. Okay? Questions with homework task number 3. Is it clear? It's for September 6th, only the odd problems, and you can start working on it right now. You already have enough examples to start working on. We're going to see more examples, but you can start working. Okay? Questions?
Only
All
odd,
clear. Oh, never mind.
Go ahead, Leo, please.
only odd.
Leo, did you have something?
Yes, my question was only odd numbers for the problems.
Yes, please. Only all of the homework tasks are going to be only odd problems. Okay. By the way, I'm just going to do a very silly and probably not funny for you guys math joke. But odd doesn't mean weird. Odd means 1, 3, 5, 7, 9, 11, So odd doesn't mean, oh, this problem isn't odd. This problem is very normal. No, don't go there. Odd means 1, 3, 5, 7, 9, 11, et cetera, et cetera. Okay, so it's gonna be odd numbers there. Now, why am I giving you the odd numbers to do? Because we're gonna solve all of the even problems in class. That's what the workshop is for. And how is the workshop going to work? That's why we did the houses. So there's the 4, I love the logos, by the way. The logos were really, really good. Really, really good. And so we've got the 4 houses. Yes, I was wondering if I had added Jesus, but yeah, I did add Jesus to the highways house. Is that correct, Jesus Aceves? No, right? Jesus Aceves, I made a mistake in your. No, you're missing Jesus Aceves. You told me that you were in Algebros.
Yes.
Yes, I did this slide. Before you had sent me the information. So let me quickly update that. I'm gonna update that. You're in house Algebros. I need to update. It's a screenshot, so I'm gonna update that. You're in that house. So each house has 6 problems that you're gonna do of the whole bunch of problems. 6 problems. Okay.
Teacher, I don't know if it's intentional, but we're still looking at Google Chrome. I don't know, we're supposed to be looking at PowerPoint.
Thank you for that. Thank you very much. It is a mistake. Thank you for that. Give me a moment. Let me switch screens here. Thank you for that. That's important. Put that here. Sorry, thank you. There we go. Each house is going to have 6 problems to solve from the homework test. Okay? You guys need to be ready to present these problems next week. Okay, starting next week. How are you going to present them? You're going to present them like you did in homework task number 2 in the diagnostic exercise. You're going to solve the problems. You're going to solve the problems as a team. And you're going to do a presentation with the solutions. Okay? There's going to be one presentation with the 6 solutions. There's 4 problems. There's 6 problems, right? I need for each team the first 3 problems at least to be ready by Tuesday, and the other 3 problems to be ready at least by next Thursday. Okay? Because what are we going to be doing next week? We're going to be going through these problems, similar to how we did with the diagnostic exercise. So I'm going to be doing some exercises, and then I'm going to say, okay, house Algebros, show us problem number 20, and you're going to show problem number 20. And we're going to talk about it, and if there's a mistake in the problem or something's wrong, we're going to correct it there. Okay? Daniel, go ahead.
59 is odd.
Oh, good answer. That should be, what should 52? That should be, that's a good observation. I'm going to correct that as well. That should be 50. Oh, I'm going to correct that. That's right. That should be, I think that problem either is not there. Yeah, maybe you guys are going to have 4 or 5 problems instead of 6. I'm going to update that. Thank you for that catch. Thank you for that catch there, Daniel. Yeah, I'm going to correct that. I'm going to correct that, and I'm going to upload it in a few moments, so you have that ready. So you're going to have your presentations next week. At least the first 3 problems by Tuesday, and at least all of the problems by Thursday. Is that clear? When the workshop finishes, I am going to upload to Blackboard. Switch back here to Blackboard. Here in the content section, there's going to be a folder that says workshop solutions to problems. Right now, we have workshop number 1. So all of the diagnostic exercises that you guys did, as well as my solutions, are here available for your review. And so, for example, anything that we needed to correct has been corrected in the solutions, okay? And so you're always going to have all the solutions there of the problems you did, and we're going to have a bunch of examples, okay? That way, you're going to have the problems that you did for the homework test, the even problems that we solved in class, and the examples that I solved, okay? So you're gonna have a bunch of examples by the time we get to the exam, okay? Questions? Is it clear what you guys need to do? Questions before we wrap up? So before we wrap up, Alfredo, can you kind of quickly summarize what I just said and or let me rephrase that. Alfredo, for next week, what did you and your house need to do? What did you need to do individually by yourself in the next week or by September 6th? What did you need to do?
Well, individually, we have to do the problems that you put on Blackboard, the odd numbers.
Perfect. And what do you and your house team have to do by next week?
Also, the problems from some odd numbers that you put the number problems on the presentation that you just showed. And we have to present those problems.
Perfect. By the way, I made a mistake and Daniel noticed it. The problems that you guys are going to be doing are 6 even problems from the homework task. I made a mistake with one of the problems. I'm going to update that in a few minutes. Okay, that's what you guys need to do. Please don't put me in a situation. Remember the houses, and the houses always give the houses in Harry Potter give points, but they can also deduct points. Don't put me in a situation where I might have to deduct points next week because the house didn't do the problems. Now, by the way, you might get stuck on a problem. That's valid. You might get stuck on a problem. If you get stuck, you can ask me, or when you present the problem, you can say, you know what, we got stuck here. But it's not valid that you guys didn't do anything, okay, without asking. Okay, questions before we wrap up? Nope, okay. This was much better for me doing this interaction and doing it this way. How did you guys feel? Compared to last class?
It's better. It feels weird when you were backwards the other day, it seems.
It felt weird for me as well to be turning my back. And I know some of you like the writing on the whiteboard, but I maybe rather sacrifice that a little bit and be able to do it this way, because when there are people in the classroom, they're still going to be able to see what I'm writing, and I'm going to be able to talk to you guys. So this felt a little bit better for me as well. But this is a work in progress, so we'll keep at it. Okay, thank you guys. I'll see you guys next Tuesday. If you have any questions, let me know via WhatsApp. Have a good afternoon and have a good weekend.
Thanks, teacher.
Thank you, teacher.
Thank you.
Thank you, teacher.